Last time, we dove into the really cool theory behind neural networks. Today, we're going to get our hands dirty. We're moving from theory to practice, and we're going to look at the incredible tools that have totally changed the game, making it possible for, well, pretty much anyone to build AI.
So let's just tackle the big, scary question right out of the gate. It's the one that stops so many people before they even start. You see all those complex diagrams, you hear about crazy things like advanced calculus, and you think, wait a minute, do I really need a PhD in math just to get started with AI?
The answer is a huge, emphatic, resounding no. You absolutely do not. And over the next few minutes, I'm going to show you exactly why. Okay, first, let's just acknowledge the fear. It's totally real. I get it. The theory behind neural networks, it really does involve a mountain of math. We're talking calculus for optimization, linear algebra for handling all the data. It's seriously intimidating stuff. And look, if you were to build a neural network completely from scratch, then yeah, you would have to code all that complicated math yourself. But here's the secret. Almost nobody does that anymore. Instead, we use these incredible libraries that do all the heavy lifting for us.
The first big name you need to know is TensorFlow. The best way to think about this is like the industrial-grade heavy machinery for building AI. It's the foundational tool that just solves that whole complex math problem for us.
So what is it really? Well, TensorFlow is an open source platform built by Google, and its whole job is to handle those super complex, low-level math operations. It's the powerhouse that the pros use. We're talking companies like Google, Uber, and Airbnb to run their AI at a massive scale. So let's stick with this analogy. Think of TensorFlow as the engine in a car. It does all the really hard work, right? The calculus, the linear algebra, it's unbelievably powerful, and it can scale up to do huge jobs. But just like a car's engine, it can be pretty complex. We say it's verbose, which is a nice way of saying you have to give it a lot of very detailed instructions. And you probably don't want to be tinkering with the engine every time you need to drive to the store, right? And that right there brings us to our second tool. If TensorFlow is that powerful, complicated engine, then Keras, well, Keras is the friendly, intuitive dashboard that lets you actually control the thing. Keras is what we call a high-level API. Now, API is just a way for software to talk to other software. The high-level part is the key here. It just means it was designed for us, for humans, to be able to read and write easily. Keras basically sits on top of TensorFlow, and it translates our simple, human-friendly commands into the complex instructions that the engine needs to do its job. Think about it. You don't need to be a mechanic to drive a car, do you? Of course not. You just use the steering wheel, the pedals, the dashboard. That is Keras. It gives you simple controls to harness all the raw power of the TensorFlow engine without ever needing to understand every single nut and bolts inside. And that separation is what makes everything possible. It lets you focus on designing cool AI, not on resolving math problems from college. So let's just recap that because it's super important. TensorFlow, the engine, does the heavy lifting, all that hardcore math. It's built for machines. Keras, on the other hand, the dashboard, is built for us, for humans. It's easy, it's intuitive, and it lets us give simple commands to control that powerful engine running underneath. Okay, so we've got our engine and we've got our dashboard. Now let's see how we actually build something. For this, let's switch to an even better analogy. Lego blocks. Seriously. With Keras, building a really sophisticated AI model feels a lot like snapping simple bricks together. Remember when we talked about the structure of a multi-layer perceptron? You know, it had an input layer, one or more hidden layers, and an output layer, all stacked up one after another. Well, Keras is designed to mirror that exact structure. And this right here, this is the magic moment. This is where it all just clicks. Look at how a complicated idea from a textbook translates directly into a simple command. That fully connected layer from the theory, in Keras, you just call that a dense layer. You need 5 neurons in that layer, you just write units equals 5. You want to use that really activation function? Just type activation equals ReLU. It's basically plain English. So building the actual structure of your AI model is, I'm not kidding, a 3-step process. First, you start with what's called a sequential model. Think of this as your empty Lego base plate. Then you just start adding your dense layers, one by one, just like you're stacking Lego blocks. And you just repeat that for however many hidden layers you want. It is really that simple. All right, so you've built your Lego structure. Now you have to bring it to life. You've got to train it. And just like building it, Keras turns training into another super simple 3-step recipe.
And here is that recipe. Step 1, create the model. That's the Lego stacking we just did. Done. Step 2, you compile the model. This is where you tell it how it should learn. You give it a strategy for improving, called an optimizer, and you tell it how to measure its own mistakes, called a loss function. And finally, step 3, my favorite part. You fit the model. You literally just hand it your data and say, okay, go learn. So what's the big takeaway here? It's that the huge, intimidating barrier of math and complex code, it's been torn down. Tools like TensorFlow and Keras handle all the hard parts for you, which frees you up to focus on the fun, creative part, solving actual problems. The question really isn't how do I build it anymore? The real question is, what are you going to build first?